Hey guys, Mr. Newton coming right back at you. I'm going to show you how to do the next set of problems and do a couple of them for you, or at least one of them, just so you got it down. All right, the next set of problems brings in our second concept. If you did the notes, you probably might have got this a little bit, but let me show you it real quick. So in addition to, I'll throw this on there, in addition to wavelength, and frequency, and then also speed. We talked about speed of light last time. You also have a thing called energy. All right, now, what would you rather have? Would you rather have a radio wave coming at you or a nuclear radiation that's going to make your kids have 9 heads and have you grow a tail and become a werewolf? Probably radio waves. So our cell phones use radio waves over in here, and that's, you know, completely harmless. And so radio waves right here going up to microwaves, so that's what you can cook your food with, and you can obviously see that, you know, it gets more and more energy as you go this direction, right? So if you are out in the sun and you're getting a tan, you're somewhere over here, right? If you're calling someone on your phone, you're somewhere over here. So these ones are not going to hurt you. These ones over here, you know, if used correctly, can kill cancer or give you kids with 9 heads. All right, so what we notice is that as the frequency goes up, right? As the frequency goes up, the energy goes up, so the amount of energy goes up. And then also look at here, as the wavelength goes down, so when wavelengths get smaller, right, so little bitty wavelengths, if they all go the same speed, little bitty wavelengths have more bumps passing a point in a second, which is why the frequency has gone up. So smaller the wavelength, higher the frequency, higher the energy. All right, so we have an equation to figure out energy. It's a little bit different, but for this particular problem right here, you have just 2 equations. The one we talked about in the last video, and if you didn't see that video, check it out. So we have speed of light equals wavelength times frequency. You can solve a lot of that using this one. And then this one over here, the new one, is energy equals Planck's constant times frequency. Now this is the same. Frequency, frequency, exactly the same. Planck's constant is another constant, and this is this one right here. And so it's always going to be this number, 6.63 times 10 to the negative 34th. All right, so multiplying that times the frequency gives you the energy. All right, so that's as simple as it is. Let's go ahead and check this out and see if we can solve. Let's go ahead and do the second row right here. They give us wavelength. Now check it out. They give us wavelength in kilometers. Can you use kilometers? No, you have to convert. Remember, when we're solving for these, we got to use those base units. So meters, meters per second, or hertz. You can't use any other prefixes. You have to convert first, solve, and then maybe convert back or whatever they ask you to do, okay? Remember that. You have to plug in the correct thing into the equation. So let's go ahead and try that. So check it out. If I got kilometers, I need to convert that to meters in order to solve for all the rest of this, all right? So I'm going to go ahead and do that first. I got 0.010 kilometers, and I got kilometers down here going to meters up there. And so if I calculate my powers of 10 difference between kilo and meters, take a look at this. This is also found on the back of your periodic table. Look, kilo is 10 to the third. We're going from 10 to the 0 to 10 to the third. So we got no prefix on the first one. And so I have 10 to the third in 1. Remember, you just count the powers of 10 separation, put it with the smaller one. So how do you know which one's smaller? Well, the one that's lower is smaller on the list. All right, here we go. So go ahead and multiply that out. That's pretty easy because you're just moving the decimal place 3 places. So I have 10 meters. So over here, this is 10 meters instead of 0.010 kilometers. Now I can solve for frequency. So let's go ahead and start solving. So my speed of light equals my wavelength times my frequency. So I'm going to use that equation. So I have 3.0 times 10 to the 8th equals my wavelength, which is 10 times my frequency. All right, so then all I'm going to do is go 3.0 times 10 to the 8th divided by 10. That should isolate frequency right there. And I've got that number right there, which is I can turn that into scientific notation if I want to go over to psi. And so that is 3 times 10 to the 7th. Okay, so there we go. So 3 times 10 to the 7th is my frequency. 3 times 10 to the 7th. And that's hertz, remember? So for energy, we're going to use this next equation right here. So energy equals HF, so that's going to be pretty easy. So I've got my frequency now. Okay, so energy equals HF. So what is H? H is a constant. It's right up here. And so I'm going to go ahead and write that in. 6.63 times 10 to the negative 34th times my frequency, which I just figured out was 3 times 10 to the 7th. All right, so now all I got to do is multiply those out. 6.63 times 10 to the negative 34th. And yep, that looks about right. And so my answer is 2. I'm going to have to round up to 2. I'm going to go 2 times 10 to the negative 26 for that one. 2 times 10 to the negative 26. There it is, right there. All right, so what is the range? So it says electromagnetic range right there. So let's go ahead and figure out what exactly that is. So if I look at my frequency, I'm in the 10 to the 7th. I like to use the frequency one. So 10 to the 7th is right here. So that puts me right in the middle of radio waves. So this one right here, this wouldn't hurt you at all. So I'm going to write radio waves right there. There you go. So in all of these, make sure to convert to the base unit. Like right here, it says kilohertz, right? You got to convert that to hertz before plugging it in. Right here, it says centimeters. You got to convert that to meters before plugging it in. And this one is megahertz. Big M is mega. You got to convert that before plugging it in. This one you can use just as is because energy has a units joules, J. So energy is using the energy unit is joules right there. All right, well, there you go. That should get you guys all squared away on that one. If you got any other questions, email me through Schoology. And you guys have a great day. Hopefully you can whiz right through those problems now.